Which type of scaling is that? It's your vertical scaling. So day before yesterday when we were upgrading our volumes and stuff, that is nothing but your vertical scaling, right? So now one thing which you need to remember, okay? One thing which you need to remember, as a part of your AWS, as part of your AWS for your EC2 service, under auto scaling, by default, it only supports horizontal auto scaling. As part of your AWS for your EC2 service, under auto scaling, by default, it supports only horizontal auto scaling. Okay. Now, if you want to go ahead with vertical auto scaling, you will have to perform that manually. AWS will not perform this job automatically on your behalf. Okay. So the other day we already saw how to perform vertical scaling and we did that job manually. Whenever I want, I can add additional resources depending on my business needs and requirement, right? Whenever I want, I can remove. Whenever I want, I can attach. That is your vertical scaling, which we did manually. Okay. Now, how do you decide when you need to go for vertical or when you need to go for horizontal? So as an organization, you need to be monitoring certain parameters, right? You would be monitoring certain parameters of your servers and resources. Let's say if the storage is getting exhausted, it's time for you to upgrade your storage. If you're seeing a high CPU utilization, you should consider upgrading your CPU counts or RAM capacity. Now, when you do this, okay, when you do this, you always have a choice whether you want to add additional resources or you want to upgrade existing resources. Now, the advantage of upgrading your existing resource is you don't have to manage one more additional server or additional resources. Now, let's say if there is only one server, you're supposed to manage that one server only. Okay. Because as a part of horizontal auto scaling, if you're adding one more server, then it would be like additional server which you need to manage and maintain. You need to ensure all the compliance and other parameters are being followed strictly. Now, disadvantage of your vertical scaling is at times, when you want a better performance, when you want high performance, and upgrading existing resources at times might not really help. And also, keeping a single machine upgraded with higher capacity and not having a backup created will also make your infrastructure single point of failure, will also make your application single point of failure. Are we all clear? Akul, is your question answered? How do you decide when you need to go for it? So that's about your vertical auto scaling and horizontal auto scaling. Remember, the disadvantage is in your vertical auto scaling, since you have only one single machine which you're continuously upgrading. So at times if that machine goes down, then it would make it as a single point of failure. But if you go with your horizontal auto scaling, where a kind of a backup machine will always be created, so even one of your machine goes down, still it will not hold any major impact on your business or on your infrastructure, right? So that's about vertical and horizontal auto scaling. So now moving a bit ahead, talking about the next aspect here. So let's assume that I have two servers, server 1 and server 2. Let's assume I have this two server 1 and server 2. And the servers are connected to your load balancer. Okay, the servers are connected to your load balancer. The traffic to this server is evenly distributed by this load balancer. Now, all of the sudden, the average CPU utilization of these two servers is somewhere around 90 to 95 percentage. Now you had enabled auto scaling. You had enabled auto scaling that whenever CPU utilization goes high, add a new server. Okay, so it adds a new server. So on this server, your application ABC is running. Here also application ABC is running. Okay, and load balancer is performing load balancing to this. So now there is a new server added, and that is also connected to your load balancer. That is also connected to your load balancer. So now help me understand one thing, all of you. By adding this new server, will my by adding this new plain server, will my CPU utilization come down? The average CPU utilization, which is at 90 to 95 percentage, will it come down? Everyone, think well and then answer. Think well and then answer. We add a new plain server and it is also connected to your load balancer. It is also connected to load balancer. So will it help me reduce the CPU utilization? So let me tell you, it will not help you reduce the CPU utilization, and neither, it will help your existing servers. Why? Because if you would have paid attention, I told that there is a new server, new plain server, which is added automatically. So this server does not have any application. Then, since there is no application on this server, how would it help you to reduce your CPU utilization? Am I making sense? Why it will not help? So just adding a plain server, just adding a plain server will not help you reduce the CPU utilization. The newly added server should have same application running as your existing server. Only then it can help you reduce the CPU utilization. Do you all agree with this? Yes? Great. So now AWS is gonna perform this auto scaling on your behalf in your infrastructure. AWS is gonna perform this auto scaling on your behalf in your infrastructure. So help me understand one thing. Will AWS be able to automatically understand which application should be installed? What should be the size of newly added machine? How many RAM, how many CPUs, how many RAM, how much of storage? All of this, do you think AWS will be able to determine automatically? Or you should define this? What is your thought around it? What do you consider would be a better option? Will AWS be able to automatically take this call, or it needs to be defined by us? So basically, it needs to be defined. So basically, you'll have to tell to AWS that whenever, as a part of your, whenever as part of this auto scaling, you're supposed to launch a new machine, please launch a new machine with this configuration, with these parameters, only then it will help in your infrastructure. Agree with me? Yes or no? Only if you define this to AWS and it uses those details to launch a new machine, only then it will help. So same goes here also. We are gonna do that. So before that, let us first have one server created. Say launch auto scaling. I'm gonna quickly launching an EC2 instance. So I say launch instances. My instance is coming up. I say command prompt. I say CD downloads. So yesterday someone asked me, I'm sorry I missed this question yesterday. Someone asked me, why do you say downloads every time? The reason why I say download is the key pair file with which I'm connecting, right? 3105. It is available in the download location. This. So I change my directory to downloads. I can directly connect to my machine. I think it was Nimai's question yesterday. So I want to quickly confirm, are we clear? Cool. So this is my EC2 instance. So I'm going to make this EC2 instance act as a web server quickly. Same thing, yum install httpd service httpd start check config httpd on cd //www/html. Copy this web code, say vi index.html, paste it up here. So basically I'm making my EC2 instance act as a web server. So the configuration is good enough for it to act as a web server. Okay. This is my outcome for what I have configured. Okay. So now what I'm going to do is I want an instance with this kind of configuration. Let's assume that a newly launched machine should have similar configuration. So how do I ensure that it has similar configuration? So to ensure that, yesterday we saw something, if you recall. Yes, you need to create something called as create image. Create image. Select this instance, say action, say image, say create image. Right? We already know how to create image. So I'll just call this as demo01 as a name of this image. So obviously image creation would take few minutes. Okay. So while image creation takes place, okay, image is same as AMI. Yes, image is nothing but your AMI, or rather your custom AMI. Instead of predefined AMI of AWS, it is nothing but your custom AMI, right? So now my image creation is in progress. While it is getting ready, here in the auto scaling section, you have two parameters, launch configuration and auto scaling group. These are two parameters in which your auto scaling is configured. One is your launch configuration, other one is your auto scaling group configuration. So understand very clearly, when I say launch configuration, what do I refer by that is what needs to be launched, what configuration should AWS use to launch a new machine. That is what you define under your launch configuration. When you say auto scaling group, here basically you're defining what kind of instances will be launched in what circumstances, or this auto scaling will take place in what conditions, when, basically when will a new instances be launched. First, in your launch configuration, you're defining the parameters that AWS should use to launch a new machine. In auto scaling group, you will define when should it launch a new machine. Are we all clear with this, everyone? Yes, everyone, are we clear? So let us quickly say create launch configuration. As a part of create launch configuration, you are telling to AWS that, hey boss, if you want to automatically scale my infrastructure, then use this configuration to launch new machine. Use this configuration to launch new machine. So I say create launch configuration. Okay. Here it is asking me for a name and other details. So let us give all of those details one by one. So let's name this as sample. Okay. Name of launch configuration as sample. AMI. So I'm selecting my custom AMI rather than any of the existing AWS AMI. I created this AMI called demo01. I'm using that. Then it is asking me for instance type. Instance type is nothing but whether you want a machine with one virtual CPU, how much of RAM and how much of CPU. So I say T2 micro is what I want. 1 and 1 virtual CPU, 1 GB of RAM. So I choose this, right? Then it gives me a choice if I want any spot instance, if I want to associate any role, or if I want to use any other parameters. So if I want, I can define all of this. Right now I don't want to, so I'm going ahead without any specific definitions. Then it is also asking me that when a newly added instance is created, which security group to be associated. So I defined that also, that associate this particular security group. Okay, which key pair to be associated. So I have defined that also, that use this particular key pair or associate this particular key pair when you are launching a new machine. So guys, are we all clear? As part of launch configuration, what you're defining is nothing but if AWS has to automatically scale, what configuration parameters should it take into consideration for the scaling? Yes, everyone, are we clear with launch configuration? Any questions, doubts, queries, something which you're still not clear, then please do let me know. All good? Great. So here I would say create launch configuration. Create launch configuration. In which scenario we choose horizontal scaling? So I think I already spoke about it. When you want additional resources and when you want to ensure the performance and other parameters, you're not taking a compromise on that part. So that is where you go with horizontal scaling. Okay, and by default, as part of your auto scaling, horizontal scaling is supported under your EC2. If you want vertical, you'll need to perform it manually. So now my launch configuration is done. The first part of your auto scaling, that is nothing but your launch configuration. Now it is done. Okay, so next is your auto scaling group configuration. So now you have defined what needs to be created. Next, you are defining when it needs to be created. Under what circumstances? Because AWS automatically does not understand whether you are monitoring CPU or you're monitoring network in, network out bytes, or you're monitoring some other parameters. Yes or no? Agree with me? And how much of CPU is high CPU according to you? Some organization having a CPU of around 75-80% is also considered as high CPU, and some organization consider high CPU only about 95%, right? So depending on your business, you need to define all of this. You need to tell AWS when should it automatically perform scaling. So select this launch configuration, say action, say create auto scaling group configuration. Create auto scaling group. So you need to give a name to your auto scaling group. Let's call it as demo. Okay. And say next. Now, in which subnet do you want new resources to be added? Basically, which availability zone. So it can, whenever it is adding, it can either launch in South 1A or in South 1B is what I have said here. Then I say next. The newly added server, do you want it to be attached to any load balancer? Then you can say attached to an existing load balancer if you want, or attached to a new load balancer. If you don't have an existing load balancer, you wanted to create a new load balancer, then you can say attached to a new load balancer. So you can define whether you want application load balancer or network load balancer, what would be the name of load balancer, whether it would be internal or internet facing, right? You can define all of these parameters and you can create a load balancer, and a newly added instance will be part of that load balancer. Okay, newly added instance will be part of that load balancer. And you can also define the health check grace period between auto scaling and load balancer, right? So now I'm just saying attached to a new load balancer. In case if I don't want to, then I could say no load balancer. Okay, the choice is always ours. So, or I can also say no load balancer, and in that case, you know, your instance which is getting created will not be attached to load balancer. So for now, I'm just attaching it to a new load balancer because I don't have any existing. So create a target group demo 01. Okay. After doing that, in the next step, it is asking me for something called as desired, minimum, and maximum. So pay attention here. Remember the values for now. I'll talk about what is desired, what is minimum, and what is maximum. Okay. I'll talk about what is desired, minimum, and maximum. If there is no load balancer, what is the point of horizontal scaling? So in that case, you'll have multiple servers on which same application would be running. So there you can be doing DNS based load balancing. When your traffic is directly hitting your server, there is no load balancer, then you can be forwarding traffic via DNS by using weighted router policy, telling that 60% of my traffic should go to server 1, remaining 40% should go to server 2, something of that sort, right? So now I said decide 1, minimum 1, maximum 4. We'll talk about these numbers also later once our load balancing is created. So I say create, next, next, next. Okay. So I'm creating a new load balancer and my instances will be attached to this newly added load balancer. Now, before I click on this create, I want to bring your attention to one small thing here. I would like to bring your attention to one small thing. At the moment, I have only one running machine. Okay. At the moment, I have only one running machine. Now I go back here. I say create auto scaling group. I say create auto scaling group. So let us wait for few moments. Let us wait for few moments. Okay. And you would notice a new instance getting created automatically. A new instance is created automatically. Now, why is this new instance created automatically when we have not defined any conditions, when we did not say when should it scale and all of that? We just created an auto scaling group, but a new instance is automatically created. Now, why is it created automatically? The reason is very simple. The reason is very simple because while configuring your auto scaling group configuration, remember we told desired as 1, minimum as 1, maximum as 4. Yes or no? Everyone, while creating auto scaling group configuration, we told desired capacity as 1 unit, minimum capacity as 1 unit, and maximum capacity as 4 unit, right? Now, what does this desired 1 signifies? The desired capacity 1 signifies that if this auto scaling group is created, if this auto scaling group is up and running, at any point of time, there should be 1 server running. If the auto scaling group is created, as part of this auto scaling group, there should be 1 server that should always be running, minimum. Okay. So if you would have said desired as 2, then it would have automatically launched 2 instances. So are we all clear what is the purpose of desired capacity, everyone? Yes. What is the purpose of desired capacity? Is everyone on the same page? Now you might tell me, Prashant, there was already 1 server. Then why did it launch a new server? So let me tell you, that server was not part of your auto scaling group. That server was independently created. Now, when you create auto scaling group, it will say, as a part of my group, do I have any server? No, I don't have any server. Then I will create 1 because my desired value is 1. So here in the activity window, you can clearly see the logs. In the logs, it clearly says a user request created an auto scaling group, changing the desired capacity from 0 to 1. Changing the desired capacity from 0 to 1. An instance was started in response between desired and actual capacity, increasing the capacity from 0 to 1, right? From 0 to 1. So that is the reason why it has automatically created a new instance. It has automatically created new instance. Now, so far nowhere we have defined any conditions that, you know what, if these conditions are met, then add additional servers or remove existing servers. We have not defined any of those kind of conditions, right? Now let us go ahead and let us understand how will your actual auto scaling work. This is so far not an auto scaling. This is because you created auto scaling group. In auto scaling group, you defined your desired capacity to be 1. So it has launched 1 new instance. Okay, this cannot be referred as auto scaling. Now we will understand what is auto scaling, okay, and how it works. So let's come back here, say automatic scaling, okay, say automatic scaling, and say create dynamic scaling policy. So basically there are different types of scaling policy. You have target tracking, you have simple scaling, and you have step scaling. Target tracking, simple scaling, and step scaling. Okay. So depending on your business requirement, automatically your servers can be created using this policies. So target tracking is a basically policy option under AWS auto scaling, which will keep track of average value Now let's say if I have 5 servers running and I set average CPU utilization is 50, then in case if the average CPU utilization of this 5 server goes beyond 50, it will automatically add a new server to ensure it is within the target value. It is within the target value. Now, what does it signify is, please understand this part here. What does it signify is, let's assume that you have a server 1 and you have a server 2. The average CPU utilization of this 2 server is coming around 60. Okay. Then it will add one more server to check if the average comes down. Now adding new server, what is the average value? After adding this new server, what is the average value? If it is less than equal to 50, then no action needed. If it is still around somewhere around 60, then it will automatically again add one more server. And then again check, okay, now I have 4 instances, what is the average value? Is it lesser than 50? Okay, no action needed. Okay. And if it is way lesser than 50, then it will automatically start removing server and check the average again. So it will automatically adjust by adding or removing capacity to ensure it is around target value. Are we all clear what your target scaling is all about? Everyone? Yes? So as a part of your target scaling, you can only define on this 4 parameter: CPU utilization, network in, network out, application load request count per target. Okay, these are the only 4 parameters on which you can configure your target scaling. Now talking about simple scaling, we'll talk about simple scaling. Now simple scaling is very interesting concept, pay attention to this. So I give a name, okay, demo 03 as a name of the simple scaling policy. Now simple scaling does not work just like that. It says what? See, I'm not going to track your resources directly. As part of your simple scaling, I'm not going to track your resources directly. You do one thing. You use some alarm service. You use your CloudWatch alarm service to track your resources. So here we need to create an CloudWatch alarm. Here we need to create a CloudWatch alarm. Now, what is this CloudWatch alarm? CloudWatch is actually a centralized dashboard. CloudWatch is actually a centralized dashboard for you to keep track of all your resources under one single window. Okay, you can easily monitor all your resources. Sorry, so you can check, you can easily monitor different AWS resources under one single window. Okay, and on one single window you will get to know the status of different resources. So here what it is saying is, you create an alarm. You create an alarm under CloudWatch. Let's say create alarm, say select metric. Okay, and it is asking us to select one of your metrics. Select one of your metrics. So I select for EC2. I say by auto scaling group. Okay, for this auto scaling group, right, let's assume if the CPU utilization, okay, to quickly trigger my alarm, I say if minimum of CPU, for continuously for 1 minute, right, is lesser than or equal to 100%. Guys, I'm giving the reverse condition here to quickly trigger my alarm. Pay attention. In your production environment, you would never say if the CPU utilization is lesser than or equal to 100%. Okay. But here I want to quickly trigger my alarm. So I'm saying if the CPU utilization is lesser than or equal to, sorry, if I say lesser than or equal to 100%, right? Then you trigger an alarm. If the CPU utilization is lower than 100%, sound an alarm. Sound a alarm condition, right? So it is asking me for alarm name. I say alarm CPU, okay, and I say next, and I create this alarm. Now I have created this alarm here. Pay attention. I have created this alarm here. I go back to my EC2. I refresh this part. I say if this alarm is turned on, if it jumps into alarm state, you automatically add a new instance. You automatically add new instance, okay, and say create. So right now, if you come back here, the alarm is not in alarm state. It is in insufficient data stage. That means it does not have enough data to immediately conclude whether it should jump to alarm condition or it should not jump to alarm condition, right? But here, the moment it jumps to alarm state, this policy will get triggered, and as a policy you have already defined add one capacity unit, and that one capacity unit will be added here. Guys, am I making sense how it will work? Everyone? Yes? Can I have quick confirmation from all of you? Am I making sense? Any doubts? So I chose CPU utilization as my alarm condition. I chose CPU utilization as alarm condition. You could have chosen any other metrics also. You could have defined on the basis of network traffic or multiple choices. Okay, that could initiate trigger of your alarm, right? Here, for the purpose of demonstration, I repeat myself, I defined a reverse condition that if the CPU utilization is lower than 100%, okay, if the CPU utilization is lower than 100%, then you jump to an alarm condition, right? So I think it has jumped to alarm condition, and here you must notice a new instance getting created. This is the newly added instance. This is the newly added instance, right? Guys, can you notice now there are three instances, and if I come back here, I show you the activity log, it will tell user requested creating auto scaling group. That was the earlier one, and here you see this, a monitor alarm CPU, monitor alarm with the name alarm CPU in state alarm triggered a policy demo 03, changing the desired capacity from 1 to 2. A new instance is added, and this is the instance ID 3903. 3903. So understand very clearly what has happened is, we said that if the alarm goes on, then you add one instance, and in alarm we defined what should be the parameter that it should monitor. Okay, the parameter monitored was CPU utilization. So I said if the CPU utilization is less than 100%, trigger the alarm. And in the policy we say that if the alarm is triggered, add one instance. And the same thing happened. The alarm got triggered, it jumped to alarm state, then it triggered the policy. Since policy was triggered, it added a new instance. Are we all clear with this? Guys, I'll tell you what is difference between minimum and maximum and desired. Please hold, don't be in a hurry. But whatever I have put across, are we clear with that? Everyone, whatever I have spoken about so far, are we clear? Why did it create in South 1A when other instances are in South 1B? While creating my auto scaling launch configuration, did I not define that it can choose any of this? Did I not define that it can launch an instance either in South 1A or South 1B? Yes or no? Guys, we did define, right? In the first step itself, in the launch configuration, while launching, when I said create launch instance, here, did I not define that in which availability zones we should be launching our instances? And also, one second, sorry. Also, while creating auto scaling group, I'm not sure if you paid attention to that. Okay. Here under auto scaling group also, we did define this, that which subnets your instances should be launched in, South 1A and South 1B. Did we select this? Yes. Did you remember seeing this screen? South 1A and South 1B. So it can launch in either of this availability zone. Are we clear why it launched in South 1A? If you would have specifically said only South 1B, then it would have only launched in South 1B. Clear? Now, what is the purpose of CloudWatch? CloudWatch is a location where you can configure alarms. CloudWatch is a location, or actually a service from AWS, which allows you to do a centralized monitoring, and that is where you can define your alarm conditions and everything. So I defined my alarm condition telling that I would like to monitor CPU utilization. In our production environment, we would have said if the CPU utilization goes above 70%, then trigger this alarm. And in the policy of auto scaling, we would have defined if the alarm is triggered, automatically add a new instance. Guys, are we all on the same page? Any confusions around this? Everyone, are we clear? Quick confirmation from all of you would help me to move forward. If anyone still has any confusion, any doubts, something which you're still not clear, then please do let me know. Manoj, are we clear now? Prasanna, are we clear? Edureka guest, are we clear? Repeat overview. I've repeated it 3 times now, my dear friend. Which part you want me to repeat again? So, depending on the load, it will add. Okay. This is your live example. It is adding instances. This is your live example. Automatically instances are getting added. Please understand, this is what your live is. I have only created one server. After that, the 4 servers are automatically created. I did not do anything. Because the alarm is going on, the moment it jumps, alarms is on, it will trigger the policy. And the moment the policy is triggered, it will add one server. Are we all clear? Now, what does this maximum capacity signify? What does this maximum capacity signify? Maximum capacity, understand very clearly. Beyond this, okay, beyond this, it will not create any further servers. So now you notice it has continuously added some 4 servers. Okay, that means what? It has, as a part of this auto scaling group, the maximum number of instances it can create is 4. As a part of your auto scaling group, the maximum number of instances it can create is only 4. Right? So I said that up to 4 instances you add it, because what if I don't set any value is it will keep on adding new servers. It will keep on adding new server. Guys, wait, please wait. Couple of people are still just bouncing back to the same part. Please pay attention. Please pay attention. Have some patience. I'm talking one by one. If you're still bouncing back to the older thing which I already repeated, it will not make any sense. I already repeated this entire overview for more than 3-4 times now. So please wait. Please wait. CPU utilization is not 100%, then how alarm is triggered automatically? Then I think you did not pay attention to the part. The condition for CPU was set to if the CPU utilization is lesser than 100%. While configuring my CPU alarm, I called it out 4 times, telling that, hey guys, I'm giving a reverse condition here so that I can quickly trigger my alarm. Because I don't have a load which will generate high CPU utilization. So for the practice purpose, what I've done is I've added a reverse condition telling that if CPU is lesser than 100%, trigger alarm. So my load is always lesser than 100%. So my alarm is triggered. And if this alarm is triggered, it is triggering my auto scaling policy. This scaling policy is getting triggered. And when this scaling policy gets triggered, here I have defined if this alarm is triggered, if this alarm jumps into an alarm state, then add 1 capacity unit. So every time it jumps to an alarm state, it will add 1 instance. And by doing this, it has added 4 instances. Still anyone confused about it? Any confusions? Everyone, can I have quick confirmation from all of you? Yes? And guys, if something which I have not spoken, please wait. If something which I have not spoken, please wait. I'll talk about it. Let me go one by one. Only then you will understand. Let's not be in hurry. I see so many people are in hurry. And that is even eventually leading me to repeat same thing over and over, because you're only focusing on your question and not focusing on what I'm trying to put across. So please wait. Let me complete. I'll open up to answer all your questions one by one. So remember, while creating this auto scaling group, I set my desired capacity as 1, minimum capacity as 1, and maximum as 4. The purpose of defining this maximum capacity is defining a maximum limit. That even after this, even after adding 4 units, if still the alarm is in alarm state, you cannot add any further instances, because the maximum capacity of this auto scaling group is limited to 4. So beyond 4 automatic instances, it will not add any further instance. Are we all clear what is the purpose of defining maximum capacity, everyone? Yes. On the same page. Next, what is the purpose of minimum capacity? Now let's say I want to remove instances. For that also I can define a policy. If I want to automatically remove instances, here I said add instances, right? If I want to automatically remove instances, then I have a provision here in the same policy. I mean, like I can modify this policy to for remove condition also, or I can create an other policy. I can create an other policy, okay, here. So ideally for your addition, you should have one alarm. For your removal, you should have another alarm. Let's say alarm one, which says that if the CPU utilization goes high, then add instances. If the CPU utilization goes down, which it should be an alarm two. So alarm two should say if the CPU utilization is low, then trigger alarm. If CPU utilization is high, then trigger alarm. If the alarm one is triggered, add instances. If alarm two is triggered, then remove instances. Instead of add, you need to be saying remove here. Instead of add, you need to be saying here remove as your condition. Okay, and you can define how many instances would you like to remove. Okay, 1, 2, 3, 4, whatever. Now let's say I want to remove 2 instances in one single shot. I want to remove 2 instances in one single shot, right? So if this alarm is triggered, it will automatically remove 2 instances. So let me delete the first policy, okay, because that is for addition. So now I'm just showing you how it will remove instances. If the CPU utilization is less than 100%, and if that alarm is triggered, it will automatically start removing instances. So we have just configured it. We have just configured it. Let us wait. So here very soon we should see instances getting removed. Now what is the purpose of minimum value is when it is removing. See, when it is adding, your maximum capacity will come into play. When it is removing, minimum capacity will come into play. Are we clear? It will not remove beyond your minimum value. Everyone, am I making sense? What is the purpose of minimum and what is the purpose of maximum now? And desired capacity we already talked about. So by default, when you create your group, this is desired. When the alarm is triggered, this is desired. When this policy is triggered, this is desired. So your desired capacity will keep updating every now and then, depending on your auto scaling policies, right? But minimum is like a landmark, telling that you cannot go beyond that. Maximum is also a landmark on the upper threshold, telling that you cannot add beyond that. Okay, very soon when this alarm gets triggered once again, we will notice that instances would be removed automatically. Now a couple of people have been asking me, here in the alarm, here in the EC2 dashboard it says there is no alarm. Yes, obviously it will say there is no alarm, because this alarm which we have created, we have not associated with EC2. The alarm is associated with your auto scaling group. While configuring alarm, while creating alarm, if you would have paid attention, right, I selected a metric, and here in the metric under EC2, I did not select any instance. I selected auto scaling group metric. Yes or no? Remember, I selected auto scaling group metric, but here in the dashboard, it is talking about each and individual instance. Since we have not associated any alarm with individual instance, so it will by default say there is no alarm associated. Am I making sense? Whose question was that? Is that addressed now? Are we clear? Since the alarm is associated with auto scaling group, the alarm is not associated with your EC2 instance. It is in the metrics what you have selected, associate alarm by auto scaling group, not by individual EC2 instance. See, If I would have associated alarm with each individual EC2 instance, on basis of that, if I would have done the scaling, then here I would have seen some alarm conditions. But here right now, I'm not associating alarm with EC2 instance. I'm associating with my auto scaling group. And that is why we don't see any alarm on instance level. I hope I'm making sense to all of you. Yes. Cool. Now there was another question continuously being asked. What about load balancer? So automatically instances are added to your target group of your load balancer. It has created an load balancer automatically. Pay attention here. An application load balancer as defined. This is your application load balancer which is created. You can review the outcome here. So this is my load balancer, and here in the target group, automatically my instances are added. You notice now it has removed 2 instances because the alarm got triggered. Pay attention. It says draining because policy might be triggered, and it is removing 2 instances, 3903 and D1 EC1. We will see very soon those instances are removed from here also. It will not abruptly remove instances. It will first drain all the load balancer connections, and then it will remove instances. Guys, and someone was asking, how would we know if the instance is healthy or unhealthy? So here it is in the load balancer window. Here you can check if the instance is healthy or not healthy. Now someone was also asking me, can we add, how to add instances manually? So here under the target group, say register target, and it will allow you to add instances automatically or manually. Are we clear with this, everyone? How to add instances to target group? So I just showed you that. Vivek, clear? Yeah. So that was about how your resources will be added to your auto scaling, to the load balancing groups. Okay. Now understand one more part of it. Someone says, without alarm, can your auto scaling work? So auto scaling can work depending on the policy. The alarm is needed because the kind of policy which we configured, it purely depends on alarm. If it's a target based, you don't require alarm. If it is step scaling or simple scaling, you would require alarm. Are we all clear? Everyone on the same page? Any confusions, any doubts, any queries? So that was about your simple scaling. I'm just waiting for the instances to be removed because the connection is getting drained on the load balancer level. That will take few minutes. It would not, abruptly close connections. It will first drain. It will allow the load balancer to drain all the load and then remove from the instances. Okay. So very soon we will see some instances getting removed automatically. That should not be any surprise. Without alarm, how instances will be launched automatically? So I think I just spoke about it. You have target tracking, define target tracking, and it will do that. So if you are selecting type of policy as your simple scaling or step scaling, that is where you will need alarm conditions. Okay. But in target tracking, you don't need any alarm condition. It will automatically, your auto scaling group will automatically keep track of targets, and accordingly it will add instances or remove instances. Are we clear? So we talked about simple scaling. Under simple scaling, we say if the alarm is triggered, add instances, remove instances. Now there is something called as step scaling. There is something called as step scaling. Now what is the purpose of this step scaling? Please understand very clearly. Okay. In step scaling, you define the alarm, but instead of adding all your resources in one single go, it allows you to add in step-by-step fashion. Now, what does it mean step-by-step fashion? Let's say, as an organization, you can add or remove in step-by-step fashion. So let's say I want to add one instance when CPU utilization is lesser than 100 and between 100 and 90. Add one instance when it is between 90 to 80, right? Or let's say remove. Remove would be more appropriate option here, right? So remove one instance when it is between 80 to 70. So it will do this job step by step manner. If the CPU utilization is between 90 to 100 to 90, it will only remove one instance. If it is between 80, it is between 100 to 80, then it will automatically remove two instances. If it is reaching somewhere around 70, okay, lesser than 100 but greater than 70, then it will remove three instances. So depending on which stage it is at, it will automatically perform this job. So instead of doing in one single go, it will go step by step manner. Are we all clear? So this can also be used in a condition telling if my CPU utilization is between 50 to 60, add one instance. If it goes between 60 to 70, add one more instance. If it goes beyond 70, add three instances in one single go. The choice is yours. Are we all clear? And you notice these two instances are terminated automatically now. I did not do any termination. These two instances are also terminated. So why these instances get terminated? Because we defined our removal policy. Yes or no? Now that's about your step scaling. Obviously, I cannot generate load step by step fashion, so we don't have demo for this. But I hope you all understood the theoretical part of it. Now, apart from that, in auto scaling, you can also create a schedule. So you can define that every day at this time, you add additional instances. Like every day, every hour, you can define kind of a cron job or a schedule based scaling. Okay. So I can define, okay, every day at this time, okay, you add additional servers. I can set start time, end time, and during that time, let's say my desired capacity should be 6. Okay, my minimum is 1, my maximum is 10. So the moment it reaches that timeline, it will automatically add new instances. Okay, it will automatically, let's say for 1 week every day at certain time, let's say 1 p.m. right? I wanted to add instances daily. Whatever is the current value, no matter what, my desired capacity should be updated and there should be those number of instances launched, right? So I can define this kind of schedule and this will work automatically again. On daily basis, automatically it will keep adding instances. Are we all clear? What is your schedule based? So schedule can be defined on, every day, every week, once, every 1 hour, every 30 minutes, depending on your business requirement. Okay. And AWS will take care of it, launching new resources automatically on your behalf on that specified timeline. That is your schedule based scaling. Now, if anyone has any questions on scaling, auto scaling, please do let me know. Now that we are done, I want to check with all of you guys. Any questions? If no question, I want you guys to quickly acknowledge telling no questions. Everyone, can I have quick responses? So all 4 EC2 instances, okay, answering one by one. Hold on. How to add and remove at a time? There should be 2 different policies. One policy to add instances and other policy to remove instances. Okay. How long the terminated machines are listed? So that would be available for few hours, but any which ways you cannot do anything with those machines. This would be available here in the dashboard for few hours, but you cannot do anything with those machines. So all 4 EC2 instance controlled by load balancer in what fashion? Round robin fashion. Load balancer is not region. I mean, you cannot control between 2 region. It is in the same region only. You cannot have your instances running in 2 different region as a part of your load balancer. What is, your thought when you say it is split based or region based? I did not understand that part. I'm sorry. By default, load balancer is deployed in that specific region, and it balances load between the resources in that region only, not between the regions. So 60/40 and all of that, when you have your infrastructure hosted in multiple regions, that can be achieved using DNS, not using your load balancer. Yesterday we talked about it. So that can be achieved using your DNS, that is your Route 53, not using your ELB. Any confusions there? The weighted mechanism, the geolocation based, the latency based, all of that we discussed in our yesterday's session, and that is achieved using your Route 53. Okay. So if you have any confusions, I would request you to once please go through yesterday's class recording, because I would like to now move forward. Repeating would not be possible. While creating the policy, we define maximum value as 4, but if the load is heavy, so can we add more instances in the same policy? You mean, can we later on edit that and increase from 4 to 40? Is that your requirement, Bitika? Yes. At any point of time later in the case, you want to change your maximum capacity, say edit here, and you can increase this 4 to 40 also, and say update, and it will be applicable. Clear? Great. So that was about your auto scaling. So now let's move a bit forward. Okay. And let us understand, because with this basically we complete our module 5. Okay. I wanted to update you that as well. With this, we complete our module 5. So now let us get started with our next module, which is your module 6. Okay. Now, as part of your module 6, we will talk about databases on AWS. Now, before I start discussing that, I want to understand from each and everyone here, what is database according to you guys? What is database according to you folks? Which stores data, storage of data, storage of objects. What about network load balancer? As informed yesterday, you need to practice on your own, okay, because the configurations are same. The only difference I have already highlighted. What is the difference? Storing data for the application, anything that stores correlated information, collection of data in an organized way is what we call it as database, where we store data being stored. Collection and storage of data in an organized manner, data storage, and we can retrieve based on criteria. Okay, fantastic. So different responses on what your database is all about. Great. So let us understand that also one by one, what your database is and how it works. Just allow me one moment. I'll just clean my dashboard for a moment. Cool. So here I come. So I say the next module, which is about your database services. Okay. So database is basically, as you guys rightly said, it is a storage of your data. Now understand, your database basically is allowing you to store your information. Now I want you to help me with one thing, because all of you guys said it is nothing but where we store our data. So I store my data in my EBS volume also. I store my data in my S3 also. So can I call them as database? Can I call those as database? Because if it is only meant with the storage, then that is also maintaining the purpose of storage, right? That is also helping you store your resources. Agree? So database is not all about storage. Couple of people who just pointed out database is all about storage, right? Let me tell you, database is not all about storage. Apart from that, understand, database is something which will allow you to retrieve that information, store that information in a particular structured manner, right? That is what we call it as database. It is different from storage in a way. In storage, your data is not organized, it is not stored in a structured manner. You cannot query your data from your storage, you cannot perform CRUD operations and all of that. Okay, but when I talk about your database, or your data, database is basically collection of data items which are stored in structured manner, and you can quickly access that information. Basically, you can query, you can retrieve that information, and you can share that information at different locations with different machines. Okay, and along with that, the security is also taken care of, right? The security is also taken care of. So database is classified as relational database and non-relational database. There are two classifications or two standard classifications of your databases. You have something called as relational database, and then you have something called as non-relational database. Now, what is the difference between relational and non-relational database? Pay attention to this. When your data is stored in a structured manner, arranged in a rows and column format, and has a fixed schema, that is your relational database. Your data stored in a rows and column format in highly structured fashion, right? And your data has a strict schema defined, a fixed schema defined, that is referred to as your relational database. When you have unstructured, semi-structured, when you have structured, unstructured, semi-structured data with no fixed schema, and data is not stored in an organized manner, those kind of data is what we call it as non-relational database. Yes or no, everyone? Yes? Agree? Your relational database, the major point which you need to remember is, has a fixed schema, whereas your non-relational database does not have any fixed schema. Now, what do you mean, Prashant, when you say fixed schema and no fixed schema, right? So let's understand that also, so that everyone is on the same page. right? So remember, in the first class, I wanted your introduction. So I had two choices basically. I would have just said, please introduce yourself. I would have just said, please introduce yourself. Now, if I would have said this, does this by any chance ensures that everyone would give me the same information? Because I ask you guys to introduce, someone might tell, hey, my name is so and so, I come from so and so country, I did my schooling here, I did my university here, then I started working here. This is first person's introduction. Second person, hey, I'm so and so, you know what, my hobbies are so and so, I come from so and so university, and all of those details. So can I say every person will have their own version of introduction? Someone might talk about their country, someone might talk about their university, someone might talk about their high school, someone might talk about their job, someone might talk about the recent project they are working on. Yes or no? Agree with me, everyone? When I say introduce yourself, obviously everyone has their own version of self introduction. It does not ensure that everyone will talk the same parameters. So this is your non-relational database. There is no one specific schema. There is no specific schema. User 1 says name, age, country. User 2 says name, university, job. User 3 says name, job, hobbies. So there is no fixed schema. Everyone is giving their information in their own version of self-introduction. Now, to avoid running into this kind of situation, I said, hey guys, I want your introduction. I want you to help me with your name, your experience in the industry, domain of expertise, country. So by putting these 4 parameters on my screen, can I say I've actually defined a schema that, hey, I want your introduction, and as part of your introduction, these are the details which I'm looking forward to. Yes or no? So now when users give me their introduction, can I rest assured the data would come in this format only? Agree with me? Yes. So this is your structured database, relational database. Data has one fixed schema. Everyone is talking only on this 4 parameters. Now in non-relational database, there is one information which would be common amongst everyone. What is that? I said introduce yourself. So there would be one information which will be common, and that is their name. That is their name. Agree? And that would act as your primary key there, or your partition key, unique identification key of your records. Are we all on the same page? Do we understand now what is relational and non-relational database? In a very layman language, I tried to explain so that even if there are people who are coming from a non-database background, they understand what it is, right? So that is your databases difference, relational and non-relational database. Now when we go to AWS, we have different database service provided by AWS. So AWS have databases across relational and non-relational databases. It also supports data warehousing and all of that. So let us talk about them on a very high level, what they are. So you have Amazon RDS, Amazon Aurora, DynamoDB, Elastic Cache. So RDS and Aurora are your relational database service from AWS. RDS supports different database engines like your MySQL, Oracle, PostgreSQL, MariaDB, Microsoft SQL, and Amazon Aurora. So Amazon Aurora is part of your RDS. It is part of your RDS. It is one of the database engine type under RDS. It is not separate from RDS. So it is actually a subset of your RDS. Okay. Just like how we have Oracle, how we have MySQL, how we have PostgreSQL. Similarly, one of those choices is Amazon Aurora. Amazon Aurora is a native database engine of AWS. You must have used Oracle, MySQL, PostgreSQL, all of that in your on-premises. But Amazon Aurora is something which is only part of your AWS. You must have not seen that in your on-premise infrastructure. Now, RDS is nothing but your relational database service from AWS. It is your platform as a service which is being offered to us. So you don't have to worry about the underlying infrastructure. Talking about your DynamoDB, DynamoDB is your key value database store from AWS. It's a NoSQL database. It's a part of your non-relational database. There is no fixed schema. DynamoDB is completely managed by AWS. Talking about your Elastic Cache, it's an in-memory cache of your database to keep frequently accessed information. Now, where do we use this Elastic Cache? Try to understand this very clearly with the example which I'm putting across so that all of you guys would be very clear. Let's assume that I have an application A. Okay. And I have my database, let's say D here. And onto my database, all my data is available. And let's assume this is an application for your McDonald's or Domino's. Let's assume this is an application for your McDonald's or Domino's. Now help me understand one thing, my dear friend. In your McDonald's, in your Domino's, is the menu fixed or dynamic? The menu, is it fixed menu or depends on every user, the menu will change? It's a fixed menu. They have some 10-15 variety of burgers available. They have few varieties of fries available. They have few varieties of soft drinks available. Yes or no? As a user, you can choose from those details. Agree with me? So it's a fixed menu, not your dynamic menu. Agree? Now let's assume that I have a mobile application of McDonald's installed in my mobile phone. Like me, there are 10,000, 20,000, 30,000 users who have this McDonald's mobile application installed. I open my application. I click on menu. The moment I click on menu, my application does a database query towards the database to fetch the menu information. Database responds to the query and gives the information to application, and application displays that information on my mobile screen. Can I say that is an ideal procedure? Yes or no? My menu is stored in database. So I open my application, I click on menu. That actually indeed creates a database query. So my application queries my database asking for the menu information. My database responds with the query, responds to the query with the information, and application receives that information and shows that information on my mobile screen. Now, in one moment, let's say at the same point of time, there are 10,000 users who click on menu option of McDonald's application. How many database queries are generated? At the same point of time, there are 10,000 users of McDonald's application who click on menu option. So how many database queries are generated? 10,000 queries. It will generate 10,000 queries because every user is clicking on their mobile phone menu, and the moment they click on their menu option, the application is designed in such a way that user clicks on menu, it should generate database query. So now if 10,000 users are clicking on menu at the same point of time, so can I say it will generate 10,000 queries? Yes or no? Everyone? Pawan, any different opinion? Edureka guest who said single query or one query. Any different opinion? Are we all on the same page? Yes? So there are 10,000 queries generated by your application in one single go. That means what? To fetch one information, you are generating 10,000 queries. Agree with me? To fetch one information, you're generating 10,000 queries. Do you think it's a sensible job? Do you think it's a sensible design or sensible way to work? No, right? Because by doing this, what you're doing is you're increasing the load on your database, unnecessary load on your database, and also you're increasing latency on your application. Because every time user clicks on menu, the application has to query database, they wait for database to respond, and then you display. So with elastic cache kind of solution, what it says, if there is a frequently accessed data, why always query your database? Have used this elastic cache. It will store frequently accessed databases, and you can get those information given to your users from this elastic cache. That way you will reduce the load on your database, and also you will improve the performance. Are we all clear in what scenario we use elastic cache kind of setup? Everyone? So elastic cache is nothing but in-memory cache. It will cache your DB queries and responses so that your application, instead of having to query this information every time, it can give from those cache. Now this is not going to store this information as your cache, it would be stored as pages. So your application does not have to query every time. Everyone, are we clear now? Your quick responses would help. Cool. So now moving a bit forward, talking about the next part, which is Amazon Redshift. Amazon Redshift is a fully managed data warehouse solution from AWS. When you have petabyte scale of data which you want to store, on that petabyte scale of data you want to perform some analysis, then you can go with your Redshift. Talking about your key spaces, in your on-premises we use Apache Cassandra workloads. Yes or no? In our on-premises, are you guys aware? For all your industrial applications and stuff, we use Cassandra kind of workloads, white column databases. Yes? Aware, not aware? No? Okay, just want to keep you informed. There is a database type called Cassandra workloads. Okay, in your on-premises, you use this kind of workloads mainly when you want to deal with all your oil and gas industry, all manufacturing units. So there, where the data generated is of different dynamos, right? Different type. So those kind of data is stored in your white column DB, which is your Apache Cassandra. Okay, it's an kind of an open source, right? And if you want a replacement or if you want a substitute of that on your cloud, right, then you have your Apache Amazon Keyspace, which is kind of a fully managed Apache Cassandra compatible workload or database service on AWS. Okay, mainly used for all your industrial application, manufacturing units and stuff. Then you have your QLDB. Okay, your QLDB is nothing but your quantum ledger database. Mainly you deal with this because it's talking about ledger. You deal in your banking environments or where you want to manage your P&L, profit and loss kind of statements and stuff, right? That is where you use your QLDB kind of databases. That is where you use your QLDB kind of databases. In your supply chain, system records, banking transaction, all of that are maintained using your QLDB databases. Then talking about Amazon Neptune. Amazon Neptune is your graphical database. So the common example is your Facebook. The common example of Amazon Neptune kind of database is your Facebook. So in your Facebook, I believe everyone here uses Facebook. Yes or no? Yes. At least you must have used Facebook sometime. Not right now. Sometime. Once. Right? So in your Facebook, there is one option. You search for any users. Let's say you open your Facebook account, you search for my name. Okay. And it would immediately tell you how many mutual friends do we have. Have you noticed that kind of setup? Have you noticed that kind of scenario? You open your Facebook and you search for your friends, right? And it will immediately tell you how many mutual friends do we have. Even in your LinkedIn, very true. Whether your first connect, second connection, first connection, third connection, all these details are given, right? So the same thing can be achieved using your Neptune kind of databases. So it will have graphical records and it can query those graphical records in span of milliseconds of latency. The very good example is this image. I'm opening it on my screen. Pay attention. Here you see. So this is how it will maintain those graphical records. Okay, kind of a mind map. So if Bob searches for Eiffel Tower, immediately Bob will get to know that one of his friend Alice has recently visited Eiffel Tower, right? So that is your graphical record database. Are we clear? What is your Neptune kind of database? Then we have Amazon TimeStream. Now TimeStream is a fully managed time series database that is used to store and analyze trillions of events per day. Mainly used by your IoT application, DevOps and all of that. Now what do I mean by that? So you have this Google Fitbits, Apple Watches, Google Watches, Samsung Watches and all of that which you tie on your wristband. Yes or no? Which you tie on your wrist, the bands and stuff, right? So in those watches, I'm not sure if you have paid attention or not. In those watches, you can track records of last 1 year also. Like last 1 year, on the same day last year, how many calories did you burn? How many steps did you walk? All this information is available. Yes or no? The Google Fitbit, the Apple Watch, the Samsung Watch, which you tie on your wrist, right? If you notice, last 1 year information is also available. And it can immediately tell you, hey, same day last year you walked this many kilometers or this many steps, this many calories you burnt and all of that. So do you think that small watch which you tie on your wrist has that amount of storage to store so much of information? Do you think that much of local storage is available? No. Every information, every step which you take, that is considered as an event, and this information is sent to the respective, owners. Like Google Watch will send it to Google, Apple will send it to Apple, Samsung will send it to Samsung, right? And this information is stored there, analyzed there on daily basis, and depending on the analysis, they also give you relevant advertisements. Now every day, let's say for continuously for 2 months, if you are walking 10,000 steps on daily basis, you are burning certain number of calories on daily basis, and you would see that in the third month you will start seeing more and more relevant advertisement to gyms, relevant advertisement to your health and nutrients constant, food items and all of that. On your Google, on your Facebook, on your YouTube, everywhere you will see those kind of relevant advertisements. Yes or no? Have you noticed that? That is because the data which is generated is being sent by that device on your wrist. The band which you have tied on your wrist is continuously sending this data to Google or to relevant, stakeholders, and they are performing analysis on that data, and they are making use of your data. Are we clear? What is your Amazon time stream kind of databases? Everyone? Then talking about your Amazon Document DB. Document DB is kind of again a non-relational database, which is very much compatible with your MongoDB. When you want to, when you want to store query and indexes of your JSON data, right? Mainly for your content management, catalog, user profile management, and all of those kind of setups, right? You use your Amazon Document DB. Like in your on-premises, you have MongoDB. If you want a replacement of that in your cloud, then your Document DB is a very good replacement. So these are different types of databases options available under AWS. Now, we already talked about what is your infrastructure as service, platform as service, software as service, or infrastructure as service. So this is about why one should consider a managed database service. So ideally in your on-premises, anything and everything is your responsibility, right? When you choose an on-premise database, you have to take care of all the aspects, right? From your power, rack stack, server maintenance, OS installation, OS patching, DB software installation, DB patching, database backup, high availability scaling, application optimization. Anything and everything in your on-premises is your responsibility. Now, when you move to cloud, you have a choice whether you want to go ahead with infrastructure as service or platform as service for your database. So when I say infrastructure as a service, please understand that you create an EC2 instance. On top of that EC2 instance, you run your database. That is your infrastructure as a service. So when you go with infrastructure as service, your operating system patch, your DB software installation, patching, backup, high availability scaling, application optimization, all of that would be your responsibility. So part of your responsibility is now taken care by AWS. The physical hardware, the OS installation, all of that is taken care by AWS. You don't have to do that. But still, all of this would be under your responsibility if you go with infrastructure as a service. If you go with platform as a service, everything is taken care by AWS. You have to only focus on your application optimization and integration. You have to only focus on your application optimization and integration. Okay, right from your power, rack, server, OS patching, DB install, software patches, database backup, high availability scaling, all of this is taken care by your service provider. All of this is taken care by your service provider. As an organization, you have to only focus on this. Are we all clear? Everyone? Cool, cool. So next is your Amazon RTS. Since we hardly have some 3-4 minutes, I'll not start with RDS today. Tomorrow when we come back, we will start with our RDS. We'll have demo for RDS. We'll have demo for DynamoDB. Then we'll discuss the other aspects, okay, in our tomorrow's session. Okay. So now if anyone has any questions, doubts, queries, please feel free to. If no further question, then I think yes, we are done with our today's session. I hope you all enjoyed the session, and I hope you all are clear with auto scaling and the database part which we have discussed so far. Yes. Everyone, can you give any real-time scenario for sample to work on topics covered today? So auto scaling, we already talked with the sample scenario only. Like when your load is increasing, you might want to increase your resources to ensure there is no performance related impact and all of that, right? So when you say any real-time scenario, what exactly is that what you're looking forward to? So when do we perform auto scaling? Normally, whenever we scale up our infrastructure, like whenever there is a load increasing in our infrastructure, that is where we would want to scale our infrastructure automatically, right? Without any manual intervention, so that there is no impact on my business, right? So it can be on the basis of the load or some conditions or some schedule based. Like let's say every day between 12 to 1 there is a peak load. After 1 p.m. again there is no load. So that you can go with your scheduled based scaling. Are we clear? Yes. Any other questions? Any questions, doubts, queries? No? Aram, any question? Okay, I tried EFS. Okay. Do you want me to unmute you to quickly understand your question? All right, allow me one moment. Yes, here you go. You're self muted. Please unmute yourself and shoot your question.
Okay, yes, hi, how are you?
I'm doing good. Thank you for asking.
Okay, I tried the EFS, the command, and
Okay,
I did everything, but you said change the region, and it has to be the same, but it did not work at all. Like it gets stuck, and then afterwards I have to press Control C to get out of to bring it to the root user or so. I don't know how, because whatever you do, I like to practice because this is
correct.
how you learn, so
Exactly.
today I was like doing it for 1 hour. I did everything. I copied your command. I did, if there was any indentation, something that I missed in the, but when you did it, it was like this and it came up. But when I tried to add like make directory iram, it did not work at all. Like it, I don't know what's going on.
Okay. Okay. So recently AWS is running into one issue. It's not, even earlier we had this issue in a Mumbai region. Okay. So do you
Okay.
have that setup ready now?
I don't, but I can send you snap shot of
No,
the
no, that's
what I
absolutely
was.
okay. I understand. But you execute a command and it does not move any forward at all. It just
No, not
stays
at all.
stuck. Correct?
Yes, sir. Yes.
Yeah, that is the situation I know. So it is observed. I mean, recently, very recently, in few AWS region, we have been facing this issue. So what I would once request is, you try it in a different region and it should work. Your steps are
Oh, okay.
absolutely correct. There is no wrong, you're not going anywhere wrong here. Your steps are correct. Because earlier we had a week back, we had similar kind of issue in our Mumbai region also.
Okay, sir. That's all. I was like, because I like to follow step by step. Whatever you did, I have to do it. That's how
Correct.
I'm learning
You'll
hands
be
on.
able to
So
learn.
that's all. I'm
Great.
not going to bother you anymore. So have a thank you
No,
so
no,
much. You have a great day. Yeah.
absolutely. You too. Thank you so
Thank you.
much.
Thank you. Bye bye.
Bye-bye. Bye-bye. All right. Any other question from anyone? All right. If no further questions from anyone, then I think, yes, we are done with our today's session. Thank you so much for all your time and patience. I really appreciate it. I wish you all a great day ahead. And I will see you all tomorrow. Till then, bye bye. Take care. Signing off for the day, guys.